Good morning, I'm Kavya, Assistant Professor in Civil Engineering Department. Today I welcome you all to a technical talk on the topic remote sensing. Now let's get started. First of all, what is remote sensing? As the name itself says, it is sensing something from a remote distance. Making it more clear, remote sensing is the technique of determining the info or acquiring the information about an object from some distance without being in actual contact with the object. That's what remote sensing is. Here what we are doing is we are analyzing the images, reflected waves coming from an object under study, and it is analyzed to obtain the information about the objects. That's what we are doing in a remote sensing basically. The remote sensing has a wide variety of application. Let's go through some of them. First one is collecting the Earth's pictures from a space. Here the sensors or cameras will be mounted on the satellites and airplane to take the images of the Earth's surface. Now, this will be helpful for determining the snow cover of the Earth, the crop condition of the Earth, soil moisture content and all. This will be helpful. Also, this data is used to determine the preparing the geological maps of the Earth using remote sensing. Also for the military applications and defense and all, this data, that is the mapping of the earth, is required. This is one application. Second one being creating the images of the ocean floor. That is, using remote sensing we can map the bottom of the ocean without actually going to the bottom. Also, it is helpful for navigating the ships through the ocean through the most optimal route. Also, we can determine the velocity of the ocean currents, quantity of the oil spills, its direction, rate of movement and all, where remote sensing is made use of. Third one is forest fire monitoring. Using remote sensing, we can determine the accurate location where the forest fire is happening on the forest, and thus the necessary preventive measures or actions can be taken. Also, the extent of forest fire is also determined using remote sensing. Next one is soil mapping. Using remote sensing, we can get the accurate soil information, what type of soil, whether it is fertile or not, what are the different strata of soil present in the earth. This all we can take using remote sensing, that too from a distant place we are determining. Also, the remote sensing has many other wide range of application in various other fields also, like forecasting the climate, warning about some natural disaster. In health sector also remote sensing is made use of. Then pinpointing our location using GPS, global positioning system, and to study how the glacier is melting and its effects on the ocean. And for navigating the autonomous vehicle. Autonomous vehicle means self-driving vehicle. Without driver, vehicle can be driven using the help of remote sensing. And also to determine the destruction that is occurred due to some natural calamity or some earthquake and all, how much destruction is happened in the earth. Like that, the remote sensing has a wide range of application in almost all fields in the world. Next, we can have a look at how this remote sensing works, or different stages in remote sensing. First one, we can analyze this through a figure. First one, there will be a source of energy. Here it is shown that sunlight is the source of energy. Some other is also there. At first the sun will be producing the energy which is traveling through the atmosphere to reach the object under study. These waves, after reaching the object, some part of these waves will be reflected. It will be captured from some satellite or some such sensors in some platforms. These waves reflected from the objects is captured by the satellite, and it is sent to the ground station, which is then analyzed using some software to determine the information about the object under study. That's how basically remote sensing works. We can go through each of the procedures in detail. That is fundamentals of remote sensing. First one is energy source. We require an energy source to produce the waves for our study. Usually in remote sensing, electromagnetic radiation is the information carrier. So we need an energy source to produce this electromagnetic radiation. For that, mainly there are two types of sensors used in remote sensing. First one is passive sensor, second one is active sensor. As in the figure, it's shown that in active remote sensing, the sensor itself produces the energy for remote sensing. It will be sending some electromagnetic waves to the object, and it will be obtaining the reflected wave from the object for study. But in passive remote sensing, passive sensors measures the reflected sunlight. How this object is reflecting the sunlight, it is measured in passive remote sensing. Thus, the passive remote sensing works only if there is sun. That is, during daytime only we can use passive remote sensing, but active remote sensing can be used at all times of the on a day, whether it can be night or day, we can use active remote sensing. That are the two types of sensors, active and passive. Next is electromagnetic wave. As I have already told, the information carrier in a remote sensing is electromagnetic wave. Electromagnetic wave comprises of electric field and magnetic field in mutually perpendicular direction, with the direction of the wave perpendicular to both the electric and magnetic fields. Here, what is important thing to note that the electromagnetic waves can propagate through any place, that it does not require a medium for its travel. That's one important thing. That's why it is used in the remote sensing. Also, the electromagnetic waves travels with the speed of the light. It is neither deflected by electric field nor by magnetic field. These are the basic properties of electromagnetic waves. Also, this is the electromagnetic spectrum. Electromagnetic spectrum shows the arrangement of different electromagnetic waves based on the frequency or its wavelength. As far as wavelength is considered, radio waves is having the highest wavelength and gamma rays is having the highest frequency. So this is how the electromagnetic spectrum looks like. Next is energy interaction with the atmosphere. During the propagation of the electromagnetic wave through the atmosphere, mainly there are two phenomena taking place. First one is scattering, second one is absorption. Scattering is a process by which the air molecules will absorb the sunlight and it will be re-emitting in different direction. Due to scattering, some of the electromagnetic waves will be lost during its travel through the atmosphere. This amount of scattering will depend upon the wavelength of the wave, the abundance of the particle in the atmosphere, and the distance of the travel of the wave. Also, the point here note that it is a scattering which is responsible for our sky to look in a blue color and for clouds to appear white. For all this, scattering is the reason. Next important phenomena occurring for the electromagnetic waves while traveling through the atmosphere is absorption. This electromagnetic radiation will be absorbed by some gases present in the atmosphere, mainly by water vapor, carbon dioxide and ozone. We all know that it's the ozone which absorbs the UV radiation from the electromagnetic spectrum and protects us. Two main important terms to note here is absorption band and atmospheric window. Absorption band is that area of electromagnetic spectrum which are absorbed by the atmospheric gases, which will be absorbed by the atmospheric gas, and we can make use of it for the remote sensing. And the atmospheric window is the remaining part of the electromagnetic spectrum, that is, which are not severely influenced by the atmospheric absorption. So, it is the waves in this atmospheric window will be made useful for remote sensing. That is absorption band and atmospheric window. Third one is interaction with the Earth's surface feature or object. After traveling through the atmosphere, these electromagnetic waves will reach the object under study. While the interaction with the object also, mainly there are three phenomena taking place. First one is absorption, second one is transmission, and third one is reflection. Absorption means some energy will be absorbed by the object, is shown in the figure. Transmission means some amount of energy will be transmitted or passed through the object. And third one being the reflection, that is, some amount of remaining energy will be reflected back from the object. This energy we have taken into consideration for remote sensing, or this reflected wave is captured by the sensors for remote sensing. As per the incident energy formula, the total incident energy will be the sum of absorbed energy, reflected energy and transmitted energy. This is how the electromagnetic radiation interacts with this Earth's surface feature or object. Fourth one is interaction of the reflected electromagnetic radiation with the satellite. These reflected electromagnetic radiations will be detected by the sensors mounted on the satellite, and these sensors will be converting this information into our useful format. Also, one important thing to note here is the resolution of the image, how the satellite image looks like. That is resolution of the image. Resolution means number of dots or pixels in an image. That is how we can clearly distinguish between 2 points. More the dots in an image, more will be the resolution of the image. That means sharper will be the image. So resolution is an important parameter to determine the quality of the picture taken by a satellite. Next one, receiving of the signals by the ground station. These sensors will be sending the information to the ground station, to the antenna. After the ground station receives the radio signal from the satellite, it will be converting it into the useful format like in an analog or digital format. And the satellite images are then processed or using specialized software for satellite image processing, and this will lead to information extraction. It can be converted to various forms as per the user's requirement. This extracted information is utilized to make decisions for solving problems happening on the earth. That is like weather changes happening on the earth surface and all. This information can be made use of. So these are the main important steps that are happening during the remote sensing process. Now getting to the conclusion, remote sensing is a multidisciplinary science which includes various disciplines such as optics, photography, computer, electronics, telecommunication, satellite launching, etc. And one of the main advantage of remote sensing is that even the inaccessible areas can be covered using remote sensing. Also, the satellite images we have taken are the permanent records that we can refer it at any time. And one limitation is that it's very expensive to build and launch satellite and all. Also, we require specialized training for the analysis of the image. However, this wide range of applications and the advantages of remote sensing makes its limitations quite negligible. That's how remote sensing solves some of the most challenging problems happening on the earth. Hope you all have gained some information regarding the fundamentals of remote sensing, its working principle, and the various fields where it can be made use of. Thank you for your kind attention.